of that definition of subcardinality. So, but how? Back again to the same set. We ask for a external similarity function about the similarity between the elements. We can build an affinity matrix. Thank you. Which is diagonal asymmetric matrix, also positive. And we are trying to find a function to get the subcardinality of that set using as input this matrix. And at this point, we only know that that's subcardinality of that set must be between 1 and between 3. And there's no equal signs here because we know that there are some intersections, so it is not possible to be 3. And also we know that those intersections are not completely, the elements are not exact, so the cardinality must be greater than 1. So we propose if we have a set and we have the affinity matrix and we have the nice properties for the similarity function, this expression, but there's more details on the paper, but this expression is nice because it has some properties. For instance, if you replace the similarity function by a crisp similarity function, saying that returning 1 if 2 elements are identical, or returning 0 if there are some difference between the elements, it reproduces the behavior of the classic cardinality. So coming back to our example and applying the approximation for the subcardinality, we got that number that seems to be quite reasonable. Well, but the problems of comparing with sets is that you are compressing the number of repetitions. So if, for instance, you are using this the approach of using sets for comparing text, and you are considering the elements at character level, if you take 2 texts of normal size in English, finally, at character level, both texts will have the same 26 letters of the English alphabet. So we need to get some information about the repetitions or about the importance of each element in order to get maybe better comparison between sets. So let's consider this scenario. We have an elephant, a bird, and a bee. From the point of view of the sets, each element counts 1. But we know that the elephants are huge, the birds are small, and the bees are very, very, very small in comparison with the elephant. So maybe we have to consider that aside of the similarity between the elements that in this case could be very small, we have to consider the weight. We have now, maybe we have here another color, those are similarities, and those is the weights of each one of the animals. So we also can use the affinity matrix and a vector including the weights. So in this case, it is clear that considering that weight, the cardinality of that set is dominated by the weight of the elephant. So we are adding this vector and in this expression in order to consider that difference. Well, how we use that idea for comparing text? This is my name, Sergio Jimenez Gonzalez. But as it happens to everyone, people make mistakes when they are writing because they know other languages. There are some ambiguity about the spellings. So let's try to assess if that written form of my name and that other one are similar or not. Having into account that each token, there's no common tokens. Every word has always a difference between the most similar words. Well, first of all, we have two sets, S1 and S2, and the union of the two sets is basically the concatenation of the two sets. And let's use as alpha and normalize the distance converted to a similarity. So normalizing, counting the number of the did operation divided by the length of the largest term, and making 1 minus that number to convert to a similarity. We can get our similarities affinity matrices, and we use alpha to compute the soft cardinality, and finally we get the cardinality of the first set, of the second set, and the union. If we have the union, we can compute also using the same basic mathematics from elementary school. We can get the intersection, and if we have the union and the intersection, we can use any resemblance coefficient to get a measure about the similarity. So using your card, we get a number that also seems to be very reasonable. It looks that Sergio Jimenez Vargas is the same Sergio Jimenez Vargas, but with some variations, with a similarity of 90%. Well, so we tried to use that idea in the name matching problem, in which we have two relations or two lists of names, and the task is try to find, even if there are some small variations in the spellings and or in the characters, try to find the right, for instance, for Fabio Gonzalez, find that in that list the right reference is the PhD Fabio Gonzalez, even that there is a S here and a Z here, and the PhD acronym. Identify the right one, the correct one, and do the same for all the other names of the list. Well, we use 12 data set name matching data sets that was proposed by William Cohen from the Carnegie Mellon University. He made a very interesting study using different similarity metrics to try to tackle the name matching problem. So those data sets includes names of birds, scientific names given by one scientist by other scientists for the same bird, and numbers of restaurants, but not only the name of the restaurant, but in some cases it's concatenated the address, telephones, and number of stars. Well, we compare of soft cardinality method with other similarity measures for comparing text. And we found for each data set, and we're reporting here the average, interpolated average precision from each one of the measures. And we found that the measure proposed by William Cohen was performed very well. We reproduced we compare with a lot of measures between among the distance, the Jarrow-Winkler distance, and many also combined with many other resemble coefficients like Dice, Jafar, cosine coefficient, Rao. Well, there's a lot of them. Well, we obtained we obtained with this method, this average result, But it happens that this is a softened version of the TF-IDF measure. Basically, this is an adaptive approach because for the similarity purposes, for computing the similarity between two names, it is necessary to use also all the information of the corpus in order to compute the TF-IDF weights. Well, 2 minutes? Yep, that's the last slide. Using the soft cardinality, that basically it is not an adaptive approach. That means that we only use the information between both strings. We get almost the same results. That looks very, very well because we don't need the whole corpus to assess the similarity between two names. And we use the weighted version using the IDF coefficients, and we will get a slightly better results than the soft cardinality.